Hey guys, we're gonna do some more Temple OS stuff, and actually, I actually have been dabbling in some HolyC stuff. I've actually learned a little bit about how to use the operating system, to its on its like programming capabilities. So, first of all, the first thing I learned is, well, not it wasn't the first thing, but it was one of the things I learned. You can do ed and then file or whatever, you just whatever or .hc.z, and here we can start programming in HolyC. There we go. We got an editor. Look at that. It's a full editor. Isn't that cool? So we can make a string here, and actually, strings are a little bit different in HolyC. In C you make them like with square brackets, but in HolyC you would put a char string, and you put U8 means unsigned 8-bit integer. Or 8-bit, yeah, unsigned 8-bit not integer. It's it's a byte. So it's an 8-bit data type. So in HolyC, instead of putting brackets like this for a string, what you do is you put a star to signify a pointer, and then you just type the string. So I am a string. There we go. And we got a string now, which is pretty cool. Although this is kind of weird how this the IntelliSense might be messing up. I don't know if that's what the actual name for it in HolyC is, but like basically the thing that colors the code based on what you put in. But okay, anyway. So we've got a string here, and now. And instead of doing printf, you can just put, you can literally just do this. So you can just put quotes and just type it, and that's it. You don't have to put in a function at all. And then we put in the char string, and then we can run it by pressing F5. And look at that! I am a string. You see that? Isn't that cool? And there's also functions that you can also make a function. Although unlike in C, it doesn't automatically run from main. So if I were to make let's see, let's make U32 main, and we're gonna put this in the main. Actually, let's indent this properly. There we go. We're gonna put that in main. If I run this, you'll see that it doesn't actually do anything. And that's because we have to. That's because we have to do this. We have to actually call it. We have to call the function, or else it won't run. So it's not like C where main just automatically runs. You actually have to call it, but that's okay. So you could do this. You could do the traditional C way of doing it, where you put the parentheses here, and you run it, and that works. Yeah, sure. But in HolyC, you don't actually have to put these parentheses here. You can just remove them, and that will run. That will actually run. Terry Davis removed he simplified a lot of the code. So if we press F5, as you can see, it still runs, which is pretty cool. Now. Although that being said, that is pretty cool, but I don't really know how you would. I'm not really sure how you would reference the function and it to be stored somewhere. Actually, maybe you would put an ampersand for the. Maybe you would put an ampersand for the address of the function. Maybe that's how you would do it. In fact, that's probably how you do it. But. Anyway, we've also got what else do we got? We've also got Booleans. So let's go over here and go over to a new line. Let me make a new line. Let's make bool I think it's bool, or no, it might be bool under. No, it's yeah. I think it's bool. Bool. Let's just call this TF for true false, and we're just gonna make this. We're gonna make this true. There we go, true. And okay, there we go. We've got a Boolean. So now I think if we go over here and we put it in here, if we put in here a if statement, if we go if TF, then we do this. Actually, I'm not sure if it's the same as C, where you can just like leave it like this. In fact, let's try it. Let's try it out. Let's see if we can just leave it like that. Error, undefined identifier, TF. Huh. Okay. All right. I might have messed something up. Okay. I'm still new to HolyC, so I don't know everything about it. Okay. So maybe we could need to put this in curly braces. Let's try it. It might not work, but we'll see. Okay, let's put it in, and you know, it might also be because I like made this wrong. I probably made this wrong, to be honest. Like I said, I'm brand new to HolyC, so I have no clue what I'm doing. If anybody knows what I'm doing wrong here, feel free to let me know in the comments. If there's any like avid HolyC users, let me know. Let me know my HolyC sins so I can atone for them. Bool. Wait. Oh wait. B. Is it B? Bool. There it is. Bool. Okay. It's bool with it's capital B and then the rest are lowercase. So that's pretty cool. But anyway, let's try it. Let's try it out now. Warning. This function should return a oh yeah, I forgot. I literally called it a U32 so that we could do this. Okay, so we return 0. There we go. Perfect. So we want to return 0. And you notice how like it doesn't break, unlike in C where like if you forget to return, it'll completely break the entire thing. In HolyC, it doesn't matter. It'll still warn you though, like it reminds you that you did it just in case you wanted to, but it doesn't need you to. It doesn't require you to return something, which is pretty cool. It's pretty cool, and I think if you were to actually like try to make the function equal something, in fact, you know what? Let's make a value. Let's make a value in here. Let's make a value. All right, let's make U32. Oh wait, I forgot. Okay, I messed. I usually use caps lock, so and caps lock doesn't really work very well with this operating system. So it's best to use shift. And you know what? That's probably good. It's probably best to use shift. I really need to break the habit of using caps lock because caps lock is kind of bad whenever you're programming. But anyway. So we got U32. So we're gonna make ret val, and this is just gonna be 0, and we're gonna return ret val, and if TF is true, then we're gonna put what are we gonna put? We're gonna put 55 in ret val. Val equals 55. And we're gonna go down here, and we're gonna make another. Actually, no. Okay. Let's see. I wonder if we could actually like supply the main function in like an if statement as one of the arguments or operands. Let's see. Okay, so let's see. Okay, we gotta do %d for decimal, and then we're gonna put new line character. There we go. Let's see if it. Let's see if this actually does. Let's see if this actually prints the return value. So this is true, so it should print 55. So let's try it. Hey, look at that, it worked! Yeah! Awesome. Cool. So yeah, you can actually return function returns inside of a print. That's pretty cool. You can't do that in C++. That's something that you can't do in C++. You know, I know I feel like HolyC is gravitating more towards C than it is C++. Terry Davis originally intended for HolyC to be like a middle ground between C and C++, and he originally called it C+, with only one plus. But he changed it to HolyC, and honestly, I think HolyC is a cooler name anyway. So yeah, cool. But anyway, I think, yeah, if we want, we can just go up here, and I think we've got yes, we have save. We can just save. Yes, Control-S saves. Okay. So we can just Control-S save, and then we can exit out. And if we just run it, I think we can. Actually, wait. I think whatever .hc.z. All right. I think. Wait, actually, hold on. Let me go look. I remember there was a way to run the files by themselves, but I forgot how. Let me go look. Programming. Let me go look. I gotta find this because it was written somewhere. Oh God, I don't remember. To be honest, I don't remember what it was. Okay. All right. How to run a HC file in Temple OS. File path. Some file. CD. Edit. Type. Find. Reboot. I'm reading a thing on. I'm reading something on Google. I'm trying to figure out how to do. Actually, oh, okay. I know what we gotta do. We gotta include it. Yeah. Okay. I see what we gotta do. Okay. Here's what we do. We go in here and we just type include just like in regular C at the beginning of your code. Let me make sure it's still recording. Okay. So you include, and then you specify the path, so you do whatever .hc.z, and it included it. Wait, then we run main. Yeah, there you go. Then it works. Cool, awesome. So now we can actually use that file. That's cool. All right, so that was some coding in HolyC. I'm still very new to HolyC, so. Yeah, I'm not really the best. Actually, hold on. I think we can do some switches too. Let's try doing a switch. Okay, whatever that. Oh God. HC that Z. There we go. Let's try a switch. Now, I think it's pretty much the same as. I think it's the same sort of thing as C, so we're gonna just do, we're gonna make a new variable. We're gonna call this, okay, so this is gonna be a U8, okay, U8, and we're gonna call this, switch, byte equals 1, and we're gonna go down here, and I think it's the same as C. We'll see. Okay, well, get it? We'll see, because it's C. Whatever. Okay, switch byte, and we're gonna do another brace here. Okay, there we go, and we're gonna do case 1, and alright, yeah, case 1, and we're gonna do break I wonder if there's a default, actually. I'm not, I think there's a default, but I'm not sure. Okay, case break. And we're gonna do, it is 1. There we go. It is 1, and then we're gonna go and do, case, and actually, you know what, I think we should do, like, I think we should indent this like this. I'm not sure how Terry should, like, indent his code. I've watched a lot of his videos, but I'm not sure how the indent switches. But hey, what are you gonna do? Okay, so there we go. We got 0 and 0, dude. And there we go. Or let's put a comma. Let's be grammatically correct. There we go. Okay, and then we're breaking again. So it should say it is 1 whenever we run this. We'll see. Let's see. How does it work? Let's try it. Okay. It is 1. Oh, but I forgot to I forgot to put a line break. Let's put a line break. Okay, there's the N for line break. There we go. There we go. Fuck yeah. Fuck yeah. Okay. Alright. There. So, it is... Or, yes, it is 1. And if we close this and do 0... if we run... And... Okay, if we run... And... It's 0, dude. Tubular. Radical, dude. It's 0, bro. Wow, man. Okay, let's put a default case. Let's put a default case. So let's go over here. And okay, we're gonna put default. And for default, let's just say I don't know what the fuck this number is. And we're gonna put a face, cause why not? There we go. I don't know what the fuck this number is. I only know 1 or 2. Okay, and then we're gonna put some crazy ass number like 5. Holy shit! Oh my god! I've never heard of a number and I've never heard of such a number. Holy fuck! Okay, we're on that. Look at that. What? I don't know what the fuck this number is, man. You only told me what 1 and 0 are. I don't know what this weird snake-shaped object is. What the hell is this? Tell me, please. What in the hell am I looking at? Oh my god, man, I don't know what the hell I'm doing. Okay. But anyway, yeah, that was some basic coding in HolyC. I hope you guys enjoyed. If you want to see more coding in HolyC, I'll be happy to do so. I mean, like, HolyC is it's a pretty awesome coding language, and it'd be pretty cool if there were actually, like, compilers that, I think there are actually compilers for HolyC that are for, like, Windows and other operating systems. Yeah, this is where the HolyC was born. Like, this is the home of HolyC. This is where you run it natively. This is where HolyC. This is the holy sacred. This is the holy sacred. What do you call it? I'm looking for the word in my brain. What is it called? This is the holy sacred. Well, it's the temple of HolyC, because it's the temple OS, dude. It's God's holy temple. It's HolyC. Hey, this is after recording. I forgot to mention one thing that I thought was actually that I thought was pretty cool. So in Temple OS, there's these little windows here that you can move around, like this, and you can, like. In fact, you can resize them too. You can resize them. This one just snaps back because it's supposed to be set to a fixed size, but it does have these windows here, and I didn't like I used to think that there were only, like, certain windows that could be like that, like, for example, the God song here, God song window. I think if you press escape, oh god. Oh, there's latches. But this is how the Temple OS generates random numbers. It uses these things called latches. I'm not exactly sure how they work, but I think they kind of flip back and forth to where, like, they're adding they're going up to the number that's there's a timer here, and this latch kind of flips back and forth between going with the timer and not. So it makes pseudo random numbers, which is pretty cool. But yeah, I didn't mean for that to come up, but that's a pretty interesting thing that we've just found by accident. But anyway, oh wait, actually, hold on. Oh no, I keep doing it by accident. Oh god. All right. Oh. Hey, there's a song. Alright, cool. That was the first time I've actually managed to get God's song to work. That's pretty awesome. Alright, well, that was unexpected, but yeah, we just got a God song. Cool. But anyway, back to what I was saying. You see these windows here. You can move them around and stuff, which is pretty cool. But, you know, I found out the other day that it's not just those tiny windows that work. And, oh wait, I think this song actually saved itself. Yeah, look. You can save the song. The song saved itself. That's cool. But anyway, I realized the other day that it's not just the tiny windows that you can move. It's all windows. Look at this. You can move everything. Everything is movable. In fact, I think this one can be moved too. Yeah, look at that. You can even move this. Everything can be moved. Isn't that freaking cool? And then we've got like CPU status here and debug information. I don't know what all of this means, but yeah, this is like this is pretty cool to have if you're like trying to look at your like what your programs are using, like how your programs are affecting the PC. But anyway, yeah, it's pretty cool that you can just like move everything. So yeah, like Temple OS is like a lot more. Once you actually figure out once you start using it right, once you like learn the ways to use it, it's actually pretty robust. And in fact, it doesn't come out of the box. It doesn't have any way to connect to the internet. But I've heard that since HolyC can just directly modify memory addresses, I'm sure that you could actually kind of make your own network driver that you can use to connect to your internet through the adapter. So I mean, technically you could connect to the internet here, but Terry didn't want it to. Terry intended for it to not be having access to the internet for various reasons. He had various reasons for that, but anyway, yeah. I just wanted to show another cool thing. Another thing you might notice whenever you're moving around these windows is that they're kind of attached to a grid. They're like they're like not. They don't stray away from like the blocks, and I think that probably has something to do with. It probably has something to do with the like resolution that this operating system comes in. Terry made it so that it only comes in one resolution. I don't know the exact dimensions, but it's like this square is the only dimensions that it comes in. And I think the reason why the CPU goes up so much whenever you move windows is because it directly accesses the memory addresses for the display. It directly accesses the video memory, and I think that's pretty damn cool. Because if that's true, then that means that Terry made it. Not only he didn't just make the compiler and the fucking assembler and and the kernel. He made everything, but he also, not only that, he didn't even really use any like BIOS interrupts. He actually made the command line, all the text, all he like made all the text functions. So he didn't use any of the BIOS text functions. He made his own. So that's pretty damn cool. It's very hard to do. It's very hard to do that because with with video, whenever you're programming with video memory and a kernel on in a virtual and not a virtual box. Oh my god, I don't know what I'm talking about. But if you try like making an operating system and you're going to be going past the real mode, which is 16-bit, you're not going to be able to use the BIOS interrupt. So you're going to have to be using the video memory, and it's kind of like x8086 assembly, where you just put in memory addresses for the different pixels on the screen, and it's like kind of like a big array for what the screen is, and you just put in characters and they appear on the screen. So he somehow managed to make Windows with that. He somehow managed to make Windows, not only Windows, but he made freaking command lines. He made printing strings and that. Like, it's insane how much work he put into this. It's just absolutely insane. And I'm not sure if it's a 32-bit protected mode that he used. It might not be, because this is a 64-bit operating system, and I'm only just getting into the details of how making operating systems work. So I don't know nearly as much as I ought to know how this works, but he did. Is basically all I'm trying to say is he did a lot of work on this, and it's extremely commendable. Like you just gotta appreciate how much work he put into this. But yeah, hope you guys enjoyed. If you want to see more, just let me know in the comments. If you want to see more HolyC coding, let me know, and I'll be happy to learn more about HolyC. It's a pretty awesome language. But yeah, see ya. Hope you guys enjoyed. Goodbye.